there we go. And page 22. Wave properties.
Okay.
Bell ringer.
Miss
And then
Farah,
of course, yes, Charlie.
sorry. Make sure I'm understanding this right.
Okay.
We're doing the thing that the the bell ringer from last week.
Correct.
Right.
We are reviewing that so that we're all on the same page moving forward into this week.
Okay.
Yeah.
Just making sure I was understanding.
For sure. Thank you for asking those clarifying questions. Okay, part A. Part A asks us to define an amplitude, a wavelength, and a frequency, and that wave properties. Right?
Yep.
So we have amplitude. We have amplitude. What is an amplitude? What is an amplitude?
Can I answer this one?
Sure. What's an amplitude?
An amplitude is the height, the height of a wave.
Yeah. So this is the height of a wave. We can also call this something fancy, maximum displacement from the equilibrium. Okay? Now, I'm going to draw a picture here because that's easiest for me to understand. So when I have a transverse wave, because they're the easiest to see amplitude on, amplitude is that maximum displacement. I've got my equilibrium, that line running through it, that rest position. The amplitude is the distance of the crest from that equilibrium. Gavin, yes, I am going to put this on YouTube. All right, next we're looking for the wavelength.
I just thought I'm a chair.
Okay. Next, we are looking for that wavelength. Kylie.
The length of one cycle.
Yeah. The length of one wave cycle. Okay. It contains one complete crest and one complete trough. Again, I'm going to draw a picture of this. Okay, so the wavelength is that area right there. That one complete crest and one complete trough. Then the last one is frequency. These should be really easy because the wave property notes are right there. Right there.
I mean, they're not exactly right there. I mean, they're right here, but
Frequency.
I'm still using the packet.
That's fair.
Like,
Frequency.
not losing anything.
Clayton, what's frequency? Oh, sorry, Gabe.
A number of wavelengths per second.
Yeah, it's the number of wavelengths or wave cycles per second. Thinking like miles per hour. Okay, we have our distance and our time. We have our distance, that wavelength, and our time.
So, let me stare at. Is this graph frequency? Can't pronounce anything.
Frequency?
Is the number of times a wave cycles in 1 second?
Yes.
Okay, it kind of glitched out.
That's okay. Okay. Now, a wavelength, amplitude, and frequency are found in transverse and longitudinal waves. Amplitude is a bit funny to find, but it is there. Clayton, do you have a question, or is your hand still up to answer the last question? Okay. Part B. Now this one was weird because this one is another graph question. You guys really don't like graph questions. Water in the background is probably me. It's probably Luigi's tank. Okay, part B wants to know, for mechanical waves, okay, amplitude is a measure of the wave's energy. According to this graph, how does a mechanical wave's energy vary or change with the amplitude? So we're looking at this graph. Our answer is going to be formulated just like all of our other graphs, as amplitude increases, decreases, stays the same. Okay, so that blank, we have to figure that part out. As amplitude increases, decreases, or stays the same, the amount of energy in the wave does something, increases, decreases, or stays the same. Okay? As amplitude does something, the amount of energy in the wave does something. So taking a look at that graph, what do we see happening to the amplitude and the energy? Gabe.
As the amplitude gets higher, the higher the wave goes, the more energy it carries.
Right. So, you guys see this? See my screen?
Yeah.
Okay, we have our graph. And we have our amplitude and our energy. So we are looking at amplitude. I'm going to pick this point and this point. Okay, so I start here and I end there on amplitude. What is amplitude doing? Increasing, decreasing, or staying the same?
Increasing.
Yes. Thank you, Gabe. So, I am seeing an increase. Now I'm going to look at those same 2 points, but I'm going to look at it on energy now. Okay, same 2 points. I start here, and I end here. So am I increasing, decreasing, or staying the same? B.
Decreasing?
So if I start, this is 0, that's my origin.
Oh,
If I
no,
start-
no.
What am I going to do?
Increasing.
Exactly. Exactly. So I know that there's not really numbers here, but we always know that that's the origin. Okay. So, looking here at the answer, we are going to say as amplitude increases, the amount of energy in the wave increases. Amplitude is a direct measure of the amount of energy in the wave. Does this make sense? I'm getting mostly blank stares and a couple of head nods. Does anybody have any questions about this? Weston, what's your question?
I meant I understand it.
Oh, I see. Okay. Yes, you understand. No, you don't have a question. Okay. All right. Well, if we don't have any questions, then let's do the last bit of this where we have to draw a picture of a transverse wave, label its amplitude and its wavelength. Well, this will be really easy because up in part A, I already drew those pieces in. So, part C. I'm going to draw it extra big so that I have plenty of room to label. Oh no, is my pen dying? No, okay. Okay. There's my equilibrium. There's my starting point. I'm going to draw my wave. Got a high energy wave this time. All right. So I need to label amplitude and a wavelength. So I've got these 2 portions of a wave. In the chat, is A or B the amplitude? Yes, A is amplitude. So I've got my amplitude here. So then B must be the wavelength. Now, for funsies, looking at this wave that I've drawn here, what could I say its frequency is? What could I mathematically count its frequency as, rounding to the nearest whole number? What would its frequency be? Put what you think the answer is in the chat. Seeing a lot of 2s, seeing a lot of 2s. I saw a couple of 3s. Anybody think 1? Charlie's thinking 1. Zep's thinking 1. So to figure this out, we are going to start at the origin. We always start, this is a graph. It's a very interesting looking graph, but it is a graph. The question is can we calculate the frequency of this wave? Okay, so we're always going to start at the origin. I'm going to count one complete crest. There's a half a wave. One complete trough. So far I have one. I've got another complete crest. There's a half. And part of a completed trough. So we're going to call this 3/4. So I have 1 3/4. That's my true answer. Or rounded, it is 2. Questions about how I found the frequency of this wave? Emily and Allison, your hand is raised.
I don't have a question for this week,
Okay.
but next week, will the bell ringer be on page 25? Like next week's bell ringer?
23 is transverse, 24, yes, it'll be on page 25.
Okay.
Yep. Clayton has sensed the ending of our class. Yes, indeed. These are the end of the notes. If you do not have a question about what we've talked about this week or last week and today, you may leave.